Okay, so we're going live. All right, welcome back. We are OOP3200. That's Object-Oriented Programming 2 in the fall 2020 semester at Durham. And it's week 4. We're talking about inheritance and polymorphism this week. What I want to do before we get into the lecture content, which is all around inheritance today, really. First of all, what is happening this week is we're going to do inheritance, polymorphism. Polymorphism at a very high level. I think we're going to hit it again later on. In class exercise 3, we're going to hit today. We're going to do a little bit of an inheritance exercise. And then as well as lab 3 has been released. Lab 3 is due Sunday. All right, so here's where we're at right now. You can see that this week we're doing kind of touching upon polymorphism, but going into more of inheritance. Talk a little bit about virtual functions, interfaces, and abstract classes. We'll talk about it at a very high level today. And then these are the evaluations for this week. Next week, if you notice, we're going to have an in-class exercise number 4 and another assignment, which is due the following Sunday. It's going to cover collections in C++, okay, as we go forward. And I think the real interesting week will be week 6 as we approach the middle of the semester, where we talk about generics and template classes. And I think that's going to be, I'm going to put it out there to you guys, a challenge for some of you to get your mind around, right? Because templates and generics are always challenging. So again, this class today is super important because it sets the stage and the foundation for what we're going to be doing over the next several weeks. Actually, if anything, inheritance and polymorphism is the central kind of theme of OOP. So I think now that we're at week 4 and you've kind of got into the C++ code a little bit and the way we're doing it together, I think you know this is going to be a kind of a critical week. But before we get to the content of the lecture today, I want to hit the lab 3 requirements. So I'm going to pull that up. And by the way, if you go up on week 4, you're going to see a little bit of a website on inheritance and polymorphism there, the lesson 4 PowerPoint that I've got in there. In class exercise 3, where you're going to submit your code today with the stuff that we're working on together. That's what this is happening. It's due, worst case tomorrow. If you can't do it tonight, it's due tomorrow night at midnight. And I'll also post a GitHub link to help you along, to kind of make sure that you practice. It's really practice more than anything else. And I think these in-class exercises, to me, are the best things that you can work with. Their YouTube recording, if for people who need to watch, watch it live and get close captioning, then you could look at the YouTube recording, which is here. And then your lab 3 details. That's the PowerPoint. You're also getting a template, which I'll talk about this right now, and I'll show you the template and what that looks like. You need to use the template for lab 3. You can't, well, let me talk about it. You may decide not to. And then there's the submission Dropbox that you can use. Okay, so this is the way it's structured today. So let's pull up the details. So here's the details for lab 3. So inheritance. Again, this is due week 4, Sunday, October 4th at midnight, and its value is 6%. It's out of 100 points, as always. But really what we're going to be doing is I'm going to be giving you a workticket.h file that's inside of a project. So let's take a look at that project that you can download. And again, these details, I'm just going to pull it up here for 1 sec here. These details are inside of your, and sorry, the Zoom is killing me today because it's changed over, so I have to admit everyone one by one, which is kind of painful. I'm just going to bring up the lab 3 template. This is the lab 3 template. There we go. And I would recommend pulling it up, please, so we can look at it together. If you have challenges with this template, I don't want you to be sidelined by it. But more or less what you're going to get is a main. I'm just going to pull this up as soon as my thing loads. So that's why I'm bringing it up here, because I want you guys to know what you're getting. You're getting a main that has errors. Like, that's the first time you may have seen that. Like, I'm getting you a template with errors. Why am I giving you a template with errors? Because right here it says fix this by implementing a working extended work ticket, or extended work ticket. Should be spelled like this. But anyways, that's what it is. You're missing the extended work ticket class, and that's why your main is not functioning, and you've got this these errors here. So what main does for you, this is your test rig, if you will. What you want to do is you want to use this so that you can check to see that your work ticket is working. So extended work ticket is something that you'll be creating for this lab. Okay, but what happens is Tom has gone along, so the originator of this course has created a couple of things for you, and I've modified them a little bit just to conform with the stuff that we're doing together. So here's work ticket. So work ticket is Tom has provided this one for you, and again I've modified it just a little bit. But basically, this, if you don't have a let's say for example lab 1 and 2. You couldn't get work ticket working somehow or something like that, then you're welcome to use this code here for work ticket. Okay, that's been provided to you. Okay, so this is kind of a working copy. It gives you kind of the solution to lab 1 and 2 in many ways, because it's got everything in here that would work with lab 1 and 2 for the most part. And you also have been given a myDate class, which is interesting in that it allows you to set dates and do all kind of stuff. myDate class is being used by work ticket, so please make sure that you use, at least if you're using this version of work ticket, then you can use you should use the myDate class as well. So those two things, myDate and work ticket, have been provided to you, as well as the modified version of console input that I gave you way back, like almost the first week. All right, so this is kind of the stuff that you've got for the lab. So what if, and this is the question I'm going to get from some of you for sure, I know it's going to happen. What if you say, well, I'm pretty confident, Tom, with my work ticket class. Can I just extend my work ticket class for this lab and use my stuff instead of this? The answer is absolutely. If you really want to use your stuff and you don't want to use this template, I'm totally fine with it. But you need to use at least this main, right, which is your test rig. So if this main doesn't work, as an example, then, because this is the way I'm going to basically mark you, I'm going to say, look, let's see if this all works. This is what is going to be testing your files out, right? So it's going to be, for example, I should be able to show work ticket as an example for ticket 1 and ticket 2. And then you notice the ticket 1 and ticket 2 are now this new class called extended work ticket. Okay, so we're going to be talking about how to make this class and stuff in a bit. So that is your template. So again, recap. Do you need to use this template? No, not exactly. I'm going to make it so that you need to use main, at least main. You need to use this. I highly recommend you use this template because it's got a working work ticket, console input, and myDate class. It's up to you though if you don't want to use it. But this part you need to use. Okay, so that's the recap for this one. The other thing is that let's go into, I'm going to close this down now. Okay, so that's the thing I've provided to you. So what you're going to be doing is you're going to make a new class called extended work ticket. So that's your job. And the extended work ticket inherits everything from work ticket. We'll talk about how to do that, and adds a Boolean attribute called isOpen, so you can check to see if the ticket is open or closed to indicate whether that's happening, right? Code has been added to the main function, like I said, in the project template to test your new class. So that's what this is. And then the details here are like normal, include an accessor called isOpen, make a default constructor that extends the base constructor, the base class, so all that kind of stuff. A parameterized constructor should initialize all inherited attributes, and from the base class as an example, as well as the isOpen attribute, and a bunch of stuff here. So please follow the directions as normal when it comes to making this stuff. So this is worth this time 70 marks instead of 65. And it gives you, I think, pretty clear instructions on what you need to do. From a programmer's requirement perspective, normally the main function has more details here, but what I'm asking you to do here for only 10 marks is just use the test rig or the main that I've given you. If you don't use the main in exactly the same way, you'll lose 10 marks. So I highly recommend you use this. I mean, it's like free 10 marks to test your code and make sure it works, you know, kind of thing. Which is good for this one because you need the extra marks. The general requirements are the same: GitHub, internal documentation, and YouTube. That's important stuff. And then there's additional optional features and things to explore, which is up to you if you want to push yourself to do more. The evaluation criteria, it remains the same, however, in terms of its spread. Okay, so that is what the assignment is, Lab 3. It's due again Sunday, October 4th at midnight, and it's to be done in pairs. Okay, questions from the class that's here right now. I think I'd like to go there before we get into more of this. Because that's kind of, I know you're going to have questions, guys, and that's what happens. You know, we have questions, they come out and all that kind of stuff, and then we, you know, but we don't talk about it until later, and that's perfectly fine. If you come up with questions from now until, you know, let's say Sunday, you know, hit me up on Discord, send me some email. I'm pretty good at responding on Discord. Email is a little bit laggy because I got lots and lots of that coming at me. So please, I'd ask if you can, if it's non-official, if you don't need an extension, or if you don't have some real official reason why you're contacting me and you just want help with your assignment, Discord is your best bet. And again, I've shared that Discord server with you guys, so you should have access to connecting with me. All right. Any questions around this? And okay, I'm getting like, you know, my work ticket class is different from this one, so I'll use this one. I'm sure I'll have questions as we go through the lecture. Yeah, totally fine. And I would recommend take a look at it. Take a look at the work ticket class that's been given to you and the work ticket class that you made, and then see what works best for you. Okay. Again, I'm giving you some leeway here because I want to make your life easier. I don't want to pigeonhole you into using the code that's provided, because it might be different than the way you implemented it, right? And I don't want you to feel compelled to do it only in one way, okay? All right, so that is your assignment details. For now, though, let's start off with our lab assignment, so the in-class exercise. And I want to get right to that because from a time perspective. So again, I'm going to start off with a brand new Visual Studio project. Please follow me on this one. This is your code along, guys. So this is just your chance to get your 2%. Again, I'm going to create a new project. I'm going to make a new console app, C++. Next, I'm going to make it so that it goes in the right spot. So again, it's going to be on the desktop inside of our files, OOP3200. And we're going to call this OOP3200 Fall 2020, and it's going to be lesson 4, right? Now you can call it lab, or sorry, in-class exercise or ICE 3. It's up to you how you want to encode this thing, but I'm just going to call it lesson 4. Okay. I'm going to create this. And what we're going to do with it is, the reason why I'm starting from scratch is because I want to go over a few things with you as well. So first things first, let's wipe all this stuff out. I don't need all this for now. And let's even get rid of this hello world. So there's nothing in here. Let's rename our source where it says, and I'll save this. Let's close this off and rename our OOP3200 F2020 lesson 4.cpp to main. So rename, call it main. I like calling it like capital main a lot of times because then then main that's inside of it doesn't get really messed up. So that's what this is, okay? So the purpose of this one is to kind of create, to kind of show inheritance and what that is, and we're going to talk about that. But I also asked you last week to grab star UML. Okay, so let's say a show of hands or a show of check marks. Who kind of got downloaded star UML? I kind of asked you guys to do that last week. Okay, so Nicholas, no, get it, Nicholas, get it. I want you to get it, and please, for the rest of you, if you haven't had a chance to do that, let's get it now because I want to use it today. Okay, I'm going to thank you for that feedback. So again, where do you get star UML? Go to staruml.io. One thing for star UML, if you download it for Windows, I don't believe it's available for Mac or Linux. So if you're using a Mac or Linux system, it's not going to work for you. Also, it's a little bit different. Someone asked me last week, what about Visio? Can I use Visio instead? Yeah, you can use Visio. You can use Visual Paradigm. You can use a bunch of other tools. One thing that this does for you that Visio doesn't do out of the box, and Visual Paradigm, which is also another great little thing, doesn't do out of the box, is actually code generate. So this actually does code generation as well, right? So that's why I recommend it. And even though it's not registered, you can use the unregistered for as long as you like, which is kind of cool. And it actually does, I found out, pretty much everything. It's completely unlocked, if you will. So I think this is pretty cool that they offer something like this for you to use, right, in the community. All right, so if you haven't had a chance to download this, it's a small download, it's not big, and we can certainly pull it up. So let's do that now. I'm just going to type in star UML and pull it up. And this is the way we're going to describe our code from now on. And one of the lessons to be learned in this week is UML, right? Okay, so now, are you with me? Do you have star UML downloaded and installed? People in the class, please. People online, they can kind of grab. I see check marks again. And if you're planning just to watch and not to do it, thanks, Nicholas. Can you indicate that by an X if you're just planning to watch? Or if you can't do it because you have a Mac, just indicate that with an X so I know you're live. Come on, guys. I want to see the X's up there too. I'm slowing down because I want you guys to do it with me. All right, so I got some people that aren't responding, so I'm just going to assume that you're not going to do it. I'm just going to move on now. Okay, great. Thank you for that feedback. So now that we have everything up, on the left, there's a couple things we talked about with star UML before. I'm going to remind you. On the left, there is a bunch of different things you can choose. I'm going to choose class. That's the first thing. So on the left, there's a class. Let's choose that. And when I choose class, I can draw my class. So I can just kind of do one of these and draw my class out. I'm going to do this first. So the first thing I do is I want to describe a couple things here. Whenever we do a UML diagram, and you can zoom in, by the way, with Control and scroll wheel, on your mouse. If you look at this, there's three little divisions. The first division is the name of the class. The middle division is the name of the attributes, fields, properties, whatever you want to call them. The third division here, this third space, is the name of operations, which we also call them functions or methods. All right, so that's what that's how you identify a class diagram like this. So if you double click on the first one, we can change the name. We're going to make a person class, which is a classic kind of example. We're going to work with this. Okay, so there's my person class. Let's do that. And again, so you person and then enter. All right. And that's the first thing. And then what I want to do is when we want to add an attribute, which is a property, I'm going to right click here and go add and then go to attribute. Please do this with me. The first attribute we're going to add is going to be an age, and then we're going to add a name. So let's do the age first, attribute, and we're going to make it so that the age attribute is m_age. That's what it's going to look like, just like we normally would code in C++. And then we want to make the visibility. So on the right hand side here, you can see that there's an editor that is context sensitive. So whatever we added here, we can modify here. So m_age, we can change this thing from public to private. All right, so now you can see minus means private, plus means public. Again, I'm assuming that you guys never saw UML, which is probably not true. I think because I was talking to Tom and he says you should know UML, or you've had some experience with it. Maybe not in star UML, but you've seen it or been taught it or whatever. So that's private, and that's the first time. The type is important too. So person for age, let's make that a type of int. So if you really want to, if you think that age should be a float, like 3.5 years old or whatever, as an example, then you can certainly change that if you want to make it a float. Actually, let's just do it. Let's make it a float. just so we can provide an age that is not just an even number. In this case, we'll make it slightly different. And let's add another attribute. So add another attribute again. And we'll add the next attribute, which will be 26 and a half. We will make it m_name, and this will be the full name. Okay. I could make it so that there's a first name and last name. That's also something we can do. Let's do that for an extended example. So first name is something that's in there. Well, again, we'll make this private, and we'll also make the type is a string. Now, important thing to do when it comes to types is we're just going to type in string, but we also have to consider that string is part of the standard template library. All right, so string, and then that's the first name. Let's do another one, another attribute. I'm going really slow here, guys, so hopefully you'll be able to keep up. Last name. Okay, so last name, and again, it's private, and the type is string. Okay. Now, on the right for UML, you'll see this in Extension Manager. Okay, this is really cool. Please go to the Extension Manager here, and notice that I have on my program here. Right, that's weird. I've got a installed. When it looks like installed, I've installed a bunch of them. One of them that I want you to grab and install is something called Generate Getters and Setters. Do you guys see that? It might be in the registry over here. Generate Getters and Setters. So if you see Generate Getters and Setters, Extension Manager's on the right here, on the top right. There's a little thing. So again, you go here. There's a little puzzle piece. It looks like on the top right. If you click onto it, Extension Manager. All right. So what I want you guys to do is, again, scroll down in the registry until you see something that says Generate Getters and Setters. All right. So it's like way back down here. Generate Getters and Setters. And then click on Install. There's going to be an Install button, please. Okay. Indicate that you've done it by checking the using a check mark in the Participants panel, please, that it's done. I also want you to download, and thank you for that feedback. It looks like some of you are doing it. I also want you to grab this one that says C++. So C++ code generation, reverse engineering. So grab this one and install that one too, please. So those are the two that I want you to install. So hopefully you've got both of those installed, okay, in a second. All right. So now that I've got those installed, I'm assuming it doesn't take long, by the way. If anyone doesn't have it installed, please indicate it with an X at this point. Great. Okay, so what you can do is, if you go to the attribute here and I right-click, you can do a couple things. You can add a constraint or a tag, right? But if you click on the attribute itself and go to Tools, you can see that there is a Generate Getters and Setters option in the Tools menu now. Do you see that? Again, how about this? If you don't see it, X. If you do see it, press the button. Like actually click on it. Click onto it. It'll actually generate a getter and setter. So again, the way it works is, I click on the attribute and I go to Tools, and then you should see Generate Getters and Setters. You guys should see that if you've installed the extension properly. Okay. So what it does is it makes these getters and setters for you. We're going to rename them in a second, but I want you to make it so that you do it for all of them. So again, I'm going to click on the attribute, then I'm going to go to Tools, Generate Getters and Setters. I'm going to click on the attribute, go to Tools, and then Generate Getters and Setters. Now I'm going to rename them so that it works, that they're okay. What they've done is they've taken the name of my field or private member, and they've tried to come up with a name that makes sense. But I'm going to say that all the getters let's just rename them. So it's get and then capital A for age, get set capital A for age, get capital F for first name, set capital F for first name, and so on. Okay, so I'm just going to go through that right now. So again, go over here to the panel where it says properties for each of the getters and setters that have been created, and just rename it so it says get age, set age. and then you're going to see what I have in a second. Again, you should be able to do what I'm doing. If you don't have that option, you can always do it by hand. I'm going really slow here, guys, so hopefully you'll be able to keep up. I'm hoping. There you go. So now we have Muzda, you may have to restart your star UML. I'm not sure why it's not showing up. Sorry, the second one was the C++ extension. So there's two extensions I got, just to let you know. So the first extension was I talked about was the getters and setters extension, this one, and I installed it. And then I also installed the C++ extension. Those are the two I installed. I highly recommend, you're probably going to need to reboot your star UML in order for you to do that. Okay? But if not, you can always just type in these operations on your own. So they're different than those in that they're in the operations area. So get age, set age, get first name, set first name, get last name, set last name. All these things here are operations or methods. They're mutators and accessor methods. That's what they are. Okay. So Ahmed, have you got everything? Did you get the menu as well, Ahmed? You said it auto restarted for you. I'm not sure if you see in the only way you're going to see the tools menu that shows generate getters and setters is if you click on something that makes sense too. Good. Excellent. So that is the first part. So the first part is we've made a person class with this, but we need a constructor function. All right, let's make the constructor function be non-default. So the way you make a constructor function here in using the star UML is, again, I'm going to right-click here, and I'm going to add a new operation this time. Add a new operation. Okay, and under the operation, right, then what you're going to do is you're going to click onto this, and on the right, you're going to rename this operation to the name of the person class, so person. Okay, there's the person class. And what we want here is the stereotype. Stereotype is going to be constructor. Okay, so you're going to actually type in the word constructor in the stereotype. It's going to look like this at the end. These double angle brackets, constructor. So this is going to identify that this is a constructor. Okay? We want the constructor to be up higher, and because otherwise it's going to be like way down here. I don't like it typically way down here. I like it usually up here. You can leave it there. It's not going to mess up your class diagram. But if you notice up here, if you look at your constructor person on the right, this is a model explorer. And on the right, you can see there's a constructor. You can actually right-click and you can say move up, or you can press Control-Shift-Up arrow every time. So if I press Control-Shift-Up arrow, I can move that all the way up until it's at the top. Control-Shift-Up arrow. So that's where that is. That's my person. My person constructor right now looks like it's a default constructor, and I don't want it to be a default constructor. What I want instead is to add parameters. And the way you add parameters to a method is if you right-click on the method or function, and I want to add a parameter. All right. So the parameter that I'm going to add in is going to be the names of the things we want to add. So the first thing I want to add is the first name. So first name. I'm going to call it first name. That's how I want the parameter to be. The first name is going to be of type string. Okay. And then add another parameter. So right click on the same thing, add another parameter. And then the next parameter is going to be last name. So last underscore name. And the type is going to be a string. And finally, I'm going to add another parameter, which is going to be a age. And I'm going to make that type of float. So what you should have now is a class that looks like this. So guys, what we've done, what we've accomplished here by doing this is a couple things, right? We've created a class diagram. This is great. And the class diagram is something that that will represent the person class, right, going forward. We want to make a subclass of the person class. So now let's go back to the PowerPoint one sec. Let's take a short break and go there for a second. And what we really want to talk about is the idea that there is we've created a blueprint, and I want to derive one class from the other class. Whenever I derive, and again, there's different names for this, the base class, we call this the base class. We just made the base class person. This is our base class. And we're going to have a child class or a subclass or a derived class. They all mean the same things. Same thing with base class. Base class, parent class, superclass, as an example. They all mean the same things. And our base class is the initial class. Our derived class is going to be our child class or our subclass. And the child class or the derived class inherits or has access to all the attributes that the parent class has, or the base class. So that means if I make another class now, and this is how you do it, I'm going to right click. Actually, I'll double click on this thing. If I double click on this thing, it gives me a little arrow. It gives me a little arrow here, right? And it says add subclass. You see that? Are you with me? So again, the way I got that is I went to my person class, double clicked on it, and I went up here and I said add subclass. Okay? If you add subclass, if you click that button, it's going to actually make another class down here. Okay? That's what it's going to do. And what we want, this arrow, this solid arrow, is a generalization. That's what it's called. And it says that this class, class 1, inherits from person. And that means whenever we see this diagram, it means that everything that is person is inside of class 1. Everything. In fact, class 1 has it has a is-a relationship with person. Is-a. So we can say that class 1 is a person. Class 1 doesn't make any sense. Let's make this thing called student. So there is student is a type of person. Student, we can say, is a person, right? Okay, does that make sense? That's the business logic. So whenever you go into a business meeting, you say, I want to make a person class, guys. Before you do any kind of code, you sketch out what it's going to look like and what stuff it has here. One thing I want to add in the person class that's missing before we go on to the student is another method that's called says hello. So let's add that in. So right click here. Again, this is a classic example. I'll make another method, another operation, and then we're going to make that operation that says hello. So we'll say says hello, lowercase s. Actually, I'll make it uppercase because that's what we've been using, says hello. Says hello needs a return type. So whenever you want to specify a return type for an operation, a method, in UML, and using star UML, I'm going to right click here. I'm going to add a new parameter. The parameter is going to appear in the parameter list, but that's not a return type. So let's just wipe out the name of the parameter here. So I'm going to go to this, wipe out the name of the parameter. It's not going to show a parameter, but we can show a direction for this parameter called return. Now it says return null because we haven't specified a return type. We can say the return type for says hello is void. So again, I did that by adding a parameter, wiping out the name, changing the type to void, and the direction to return. There's different directions, in, out, and return. We're just going to make it so it's return. Okay, so that's how it looks. Says hello. So says hello is a function that's going to basically say hello. Person says hello, and the student is going to inherit all this stuff, everything. Okay, let's make a couple things for the student. One thing I need for the student, let's start with the constructor function. So I'm going to right click, I'm going to add a new operation. The new operation is going to have the same name as the student name, so student. The stereotype is going to be constructor. Okay, there's the constructor. And the student constructor is going to take first name, last name, and age, as well as a student ID. Let's do that. So let's add those parameters in here. So I'm going to add a new parameter called first name, and it's going to, the type is going to be string. And I'm also going to add another parameter called last name. And the type is going to be string. I'm going to add another parameter called, you should be able to do this now much quicker, called age, and the type is going to be a float. And I'm going to add the last parameter, which is new, which is a student ID. It's going to be called student underscore ID, and the type is going to be a string. So that is the constructor function for the student class. The student class is a person, and what we're going to do is we're going to pass first name, last name, and age into the base constructor for the person class. Because whenever we have a constructor of the derived class or child class, it has to satisfy the requirements of the constructor in the base class. That means when I construct or instantiate an object of type student, it's also instantiating inside of it an object of type person. Okay, let's continue. It's missing, we're missing a couple things here. One thing we're missing is the new attribute. We're going to add another attribute, and the attribute that we're going to add here is m underscore student ID. Okay, that's the attribute. The attribute is going to be of type, it's going to be private, and it's going to be of type string. Okay. Again, for people who have joined, I think we had a late joiner, Mikhai. We're using star UML to describe our person and our student class. So what we're going to do here, again, it's being recorded for you, so you can always watch this recording later. Okay, so again, here's our student class. Here is our student ID. I want to create a getter and setter for this thing. So again, I'm going to click on this, go to Tools, and kind of click on Generate Getters and Setters. It's going to make these. They just need to be renamed. Let's name them what they're supposed to be named. So it's get student ID and set student ID. Okay, get, set. And the only thing that I want that's different that the student ID adds, we added a student ID itself, but I also want to add a studies method, right? So I want to add a new operation. We're going to say that students can study. So we're going to say studies is the operation or the function. The visibility is public again because it's a method, and I'm going to right click and add an empty parameter. We're going to wipe out the parameter again. We're going to make the type void and the direction return. Okay, so studies is going to return void. One thing we're missing from our person class, it would be nice to have a way of outputting complete person, that age, first name, last name, and all that kind of stuff out. And let's overload the toString operator, or make a toString method. So here in the person class, we're going to add a new operation. We're going to call it toString. Okay, like this, toString. toString is going to return, I'm going to add another parameter, an empty parameter to toString. We're going to wipe this out, and we're going to make the type that it's going to return a string, and the direction is going to be return. So this toString method is going to output a string of a person. The person property is going to be output. I also want a toString method to include my student ID when I'm a student. So we're going to overload the toString method down here. So down here, I'm going to right click, I'm going to add a new operation. And the operation down here is going to be the same. It's going to be the toString operation, toString. The stereotype we're going to put in is overload. So we can specify that this is going to be overloaded. It's an overloaded toString method, right? I'm going to add a new parameter that's an empty parameter again. It's going to return string, and the direction is going to be returned. So what I'm specifying here is a couple things. I'm going to allow myself to make a toString method, and then I'm going to change it or override it down here. Are you with me? Check marks if you're with me. X if you don't know what the heck I'm doing. And, you know, or if you're completely lost or you need more time. Notice something here when we drew this out, and this is part of our lecture example, okay? When we drew this UML diagram, when we're doing this kind of stuff, right? If you think about this, look at the diagram. Do you see that the person class is actually not as wide, right? I'm just going to clear it. Thank you for the feedback. It's not as wide, the person class, as the student class. The student class is actually, I'm going to say this again, fatter in many ways than the person class. In fact, we can say that all children of parent classes or super classes, all the children classes or derived classes are fatter than their parents. Not true in real life. In real life, it's the other way around. It's, you know, parents are usually fatter than the children. But in object-oriented programming, all the time, our memory footprint for our child classes is always larger, more than our base classes. Why? Because our student class or our child classes include everything from the base class plus more stuff. In fact, we can say that our child class is a more specialized version of our parent class or super class or base class, whatever you want to call this. It's all the same words. So more specialized version is student class. Okay? Let's continue. I'm just going to zoom out here. Again, I'm going to use Control and scroll wheel to zoom out so we can have more room in our diagram. Move this student class over here. And I want to add another class, right? I want to add another class to this. And the other class I want to add over here is a teacher class or a professor. Let's make it a professor since we're in college, right? So again, the way to do a new derived class easily is double click on the parent class. Oops, let's try that again. Double click on an empty spot in the parent's class. And then you're going to see this little button that says add subclass. So I'm going to click add subclass. It's going to add another class. And let's do that whole exercise again, right? So what I want in here in my class is if I double click and I go professor, right? So there's my professor. And what does the professor have that's different than the student? First of all, question for you guys here, without doing anything different. Is a professor a student? Think about this. Check mark for yes and X for no. I see a bunch of X's. Yay! That you guys are getting it. All right? That's awesome. The professor is not a student. However, the professor is a person, believe it or not. The professor is a person, right? Student is a person. But the professor and the student are different specializations of the person class. I know. You don't think professors are people. I get it. So a professor doesn't have a student ID, but they have an employee ID. Let's make that happen. So we're going to add a new attribute, and we're going to add a new attribute, and we're going to call this a m_employee ID. Okay. And we're going to make it private, of course, and it's going to be of type string, if that makes sense. And we're also going to have a new attribute, a new operation, which is the constructor function. So again, the operation is going to be called professor, and the stereotype is going to be constructor. And inside the professor constructor, we're going to add a new parameter, and the new parameter, as you may have guessed, is the first name. We're going to do all the same things. So add the same parameters, please, for the student class, except for we're going to also add for a poll for an employee ID here. So let's do that together. So again, I'm going to add in first name, it's going to be of type string, and I'm going to do another one. Last name. You're probably faster than me. That's good. And age. Type is float. And add another parameter. We're going to call this parameter employee ID. Okay, and the type is going to be a string, because we probably have more complicated employee ID. I'm just going to make this star UML bigger so it takes up all of our screen so we can see this. Okay, so again, we have two things: a person and a student and a professor. The professor has first name string, last name string, age to float, employee ID, which is a string. We have an employee ID member variable, and now we need to get the getters and setters. We're going to do that. You can see where I'm going with this. It's the same thing that we've done in all the other cases. We're just going to change the names here. Get employee ID, set employee ID. So why did I go to all this extension and extended stuff with UML? Because it's a great way of describing what we're going to be doing in a second in code. We're going to do all the same stuff in code. So a professor doesn't study necessarily. A professor will teach. So let's say teaches. All right. And their professor can also have classes and a bunch of other stuff. So do students. So that's where they're the same. Let's go into an operation. The professor is going to teach it, to have the teaches operation. The teaches operation is going to have a single parameter, which is going to be an empty parameter for now. The return type is going to be void, and the direction is going to be return. It's also going to have a another operation called toString, which is also going to have a stereotype of overload. Right? It's going to be an overload. You can say overload or override here. It's the same thing. But it means different things in different programming languages. So our toString is going to actually have also a parameter that's empty. Remember? I'm not going to take anything here. And our parameter is going to return a string, and it's going to have the direction of return. Okay? So when I zoom in, you can see that these are the classes. Notice that the approximate size of our professor class, that's not what I wanted. The approximate size of our professor class and our student class is about the same size, right? In terms of number of parameters and so on, types of parameters we're using. So memory footprint wise for both of these classes should be approximately the same. I'm just going to kind of grab all this and move it over as one big chunk, right? So that is what we're going to do. Now, we know that the overload or the override that we're going to do for the toString method. And by the way, what we want to put, we want to make another override, or we want to use another stereotype up here. We're going to call this virtual. So virtual is a toString method up here. Virtual here, down here, we're going to have a overload. We can also call this override. Okay, let's change this to override, just so I don't confuse you, because overload can be used for overloaded operators, and so on. Notice we haven't described any overloaded operations or anything like that. We can't add two students together necessarily. We can't add people together. We can't really compare people, except we can say, is this person the same as this person, right? So there's some stuff that it doesn't make sense. Some of it doesn't make contextual sense to have some kind of operators. Although the in operator and the out operator, the double greater than sign or angle brackets right, angle brackets left, those probably make sense to overload. Maybe want to do those. Also the copy constructor, we probably want to do that. The assignment operator, those make sense, right? But the rest, really, at the end of the day, is just going to be this. Okay, so you should have what I have now. This is what I want to build. We know that professor is going to be different than student. We know that we want to build a person class. How do I make it so that I have some fun doing this? And it's not going to take me a million years to scaffold this out because I don't want to. Well, if I go to my desktop where I have my OOP3200, there it is. What we can do is I'm going to make a temporary folder. So I'm going to call make a new folder called temp. There's a reason for this. Right? In my temporary folder is where I want this stuff to come out, right? So I can use some of this just stuff that I just made, right? As opposed to have nothing. So how do I do this? Well, this is where it may work for you guys and it may not, okay? So I want to go over to tools and I want to go and, well, one thing is on the right over here, notice that there is a person class, and then up above there's something called model, right? Model is the model that we're making for this entire thing. Let's rename the model, something like OOP3200. Okay, so the model is OOP3200. That's the thing underneath the Untitled. If I click Untitled, Untitled is actually the project name. So this is OOP3200-F2020, and then it's like lesson 4, right? The author is me, or it could be you in this case because you're doing it. The company is Durham College. And copyright, sure, is 2020. And version is 1. So that gives us some information about the project. And if you click here on the bottom, if I right click, right, then I can diagram. I can add another diagram if I want, or do other things. But what I really want to just left click on this thing here, the model, which we changed to OOP3200. If I go to tools now, and if I go to C++, and if I go to generate code, it's going to ask me what do I want to do. I want to click on OOP3200. And then I want to press OK. So again, let's go back before I do this. Tools, C++, generate code. You should have this menu. If you don't, it's okay. All right, we'll do it by hand. Then you're going to go to OOP3200 and press OK. It's going to ask where you want to go with this, which folder you want to export to. I know where mine is. You should know where yours is. I'm going to choose desktop. I'm going to go to OOP3200 in my temp folder. I'm going to click select folder. Okay, you don't see any output from star UML here, but if I go into that folder now, I'm going to see an OOP3200 subfolder. Inside there, I got all my classes, guys. Guys, this is an amazing thing. All right, I'm going to grab all this stuff. I'm going to also open up my folder for where my actual my project is right now, which is inside desktop, inside OOP3200, inside of lesson 4. This is lesson 4. And inside of my OOP3200 F2020 lesson 4 area, where my main sits, in the same folder where my main is, I'm going to copy paste, not drag and drop, copy paste from here to here. Okay, so I've got the same files. I got files from here and I put them in here. Now there's some fixing we're going to have to do. Okay, this is not free what we just done. But fixing is far easier than making a new. Okay, as you're going to see. So we got person class, person CPP, professor class, and so on, and student class. Okay? Are you with me? Were you able to generate these things? If you weren't, it's totally cool. If you were, that's awesome. That's going to save you a pile of time. And there's nothing wrong with doing this for your lab 3, the one that you're going to construct. In fact, we can reverse engineer a class that's already in existence. For example, one of your classes, you can use the reverse engineer option. Thank you for this. And what you're going to do is you can actually pull a diagram in that from a class that already exists. Okay. Now, just because I've pulled this in doesn't mean C++ and my Visual Studio application understands what this is yet. So if I go back to Visual Studio, do I see it here? No. I need to add it in. And the way to do that is, in my source files, I want to put all my CPP stuff, right? In my header files, I want to put all my .h stuff. So let's go in my source files, and I'm going to right-click and add existing item. Add existing item. After copying this files, in which folder should I paste it? Inside of your folder for your project. So the way you can find your project of your project is you right-click on your project, and you go to Open Folder in File Explorer. And then you go into this folder that says OOP3200 F2020 Lesson 4. It's got to be in the same folder as your main.cpp. Okay, that's where you want it. Again, if you haven't got this, you can always go look at it on the video. But I want to right-click and I want to add existing item. And then I want to choose all my CPP files, only my CPP files. So left-click, Control left-click, all my CPP files, and then click Add. I want to do the same thing for my header files. I'm going to right-click here. I'm going to add existing item, and I'm going to add in all the .h files. So .h, and add. Guys, we've got some stuff here that we didn't have before, right? And you know what? This is a great spot to put it up on GitHub. So worst case scenario, if you haven't got any of this stuff, you can just use my GitHub. So how do I do that? I'm going to add to source control, Git. This gets added to source control, and then I'm going to go to Team Explorer, right? I'm going to go to Publish to GitHub. I'm going to choose Durham Programmer, right? And it's going to be called OOP3200 F2020 Lesson 4, and click Publish. And what this is going to do is going to push everything up to Git as is, the way I have it. I haven't modified any of the classes or anything like that, and you will have everything I have if you want to start from there, right? And let's take a look at that GitHub repo now and see what it looks like. So if I go to github.com and we'll go Durham Programmer, then you're going to see that there's a link here, OOP3200 F2020 Lesson 4. I'm going to click on that link. I'm going to grab this link right here for you. And I'm going to put that inside of your ICE for today. In class exercise, I'm going to make a new link. And I'm going to call this GitHub Repo for week 4. All right, so even if you couldn't catch that, it's inside of your DC Connect. It's up on DC Connect, please go there. And if you look at the in-class exercise submodule, you'll see that there is a GitHub repo for week 4 now. Okay, worst case scenario, if you couldn't do what I did, example, people that came late, Mihai, grab this one, download it, and start a new project from here so you can continue with me now. So you don't have to worry about, I couldn't do it, I didn't have star AML, things aren't working, blah, blah, blah. You have everything, just download the repo. The way to download the repo again from GitHub for people who don't know is you can just go to go to the code and download the zip file. And then from there, if you unzip it, you should be able to follow along. All right, so hopefully that helped. Let's take a look and see what craziness we got from this stuff. So let's take a look first at our person class, person.h. What does this look like? Whoa, lots of errors, right? But not really. Not really though, right? And the reason why there's not a lot is because these are just our standard. We can actually use namespace standard if you want, and string would work, or I would do something different. First of all, let's add a pragma once on the top. So we'll say pragma once, because I want to make it so it's got both the guard and as well as everything else. Notice it added on in our guard for us, person H like this. I'm fine with that. Let's leave it alone. I'm not going to change this. And it says here with my, look what it says here. With me, it says string. My resharper C++ is saying we should probably add string. Okay, let's do that. So now string has been added. And what I want to do is I want to go, I'm just going to undo that here. I want to go and I want to search for all references of string in here, and I want to change it to standard string. So I'm going to say Control A, Control F for find. We're going to look to see if there's a string, and I'm going to change it so it says standard string, and then replace all, which is this button right here on the right. Okay, and now everything is a standard string. And if I messed up, That's okay. I think I did. Let me undo that change. Because I also have a... actually, no, I didn't. I didn't do that. It didn't mess up. What it did was it put the type first. So let's replace all that. Did I not do it? Sorry. Control A, Control F. Looking for string and replacing with standard string. Yeah, so it's okay, but if you're getting these errors where it's still not working, it's because up here it can't be standard string, it's got to be string. There we go. That should work. Yeah, pretty good. We can't have person become void because that was just that came from our constructors. We're just going to make this so it goes like this. Right, it's not going to be void. Right? Person is actually a constructor. We have get age and set age, and we have set first name and get last name, and so on. We have all these things. Says hello. We also have a toString function, and we have some private member variables. Look at all that. Did all that for us, guys. Right? So that's our class. Like, it actually made our person class for the most part. Right? And this way we didn't waste too much time doing all this stuff. That's why I wanted you guys to do star UML. All right. So that's the first part. Okay, next part. Let's fix up our person.cpp class, our person.cpp file, because there's some stuff we have to fix. One of them is this person void. It doesn't return void, obviously, right? It returns the type person. So person. Here, the same things have to happen. What we want is to do a replacement. So Control A, Control F. We're looking for string. We're replacing it with standard string and replace it. You can also use namespace standard if you really don't want to. And we have a bunch of, look at this, we have a bunch of scaffolded pieces for our person class, yeah? Ready to go with values and everything else. There's still some things that ReSharper C++ recommends. For example, ReSharper C++ says our person class, it says that initializing field m first name from constructor parameter first name. So if I click on this, it does this. That's okay. I like that. And it tells me to do the same thing for last name. So let's do that. Initialize field m last name from constructor parameter last name. Yay. And the same thing goes with age. I definitely want to do age because we're missing it. So we just can continue that initialization. By the way, if it's too wide for you, there's nothing wrong with putting the initialization down here on the next line, just so that I can show you what it looks like. Make that bigger. We can add in the age as well, because age hasn't been initialized. We'll say m underscore age is equal to age. So this is the initialization script that it's done. And it says, hey, maybe you initialized it in the wrong order, as an example, because it'll say that if I go here, the order of initializations is wrong. That's okay. Let's reorder things. Okay. Float age also could probably be a const. So this is kind of some stuff that we've done before. Guys, we have first name, last name, and age, and our constructor for the person class is done. Okay, you should have something similar. All right, let's do our getters and setters. So our get age is not going to return 0. Our get age is going to return m underscore age. Right? And we're going to make this a const member function because it's just going to return this. So that's that one. Get age. Let's go to set age. Set age, again, we're going to say that it's going to be m underscore age is equal to value. That's a common way of doing it. We can make value a const. Okay? Let's keep going. Get first name. Again, we can say that we're going to return m underscore first name. And what we want to say is that we want to make this member function const. Okay? Let's keep going. Set first name. M underscore first name is equal to value. Now here they're going to recommend doing a move, kind of motion. And if you notice, it says add const. And we're also going to use a move. It says apply clang tidy fixit for performance unnecessary value parameter. We don't want to pass by value. We want to pass by reference. And that's what this has done for us. Because if we pass by value, we copy the entire string over, as opposed to we pass the reference of a string. Because it's a string type, it's a complex type, we pass it through the setter here. Let's keep going. Let's do our last name now. Our last name, let's keep going, is we're going to return m underscore last name, right? And it's going to be a const member function. And we're also going to do set last name just like before. If you've done it faster than me, guys, you're welcome to go faster than me. I'm going to go slow. I'm going slow so we can capture everything, right? And then I'm going to say set last name, m underscore last name, as an example, is equal to value. And again, we'll do the same changes. Const, as well as we'll make it so that it is passed by value. Says hello and toString are where we have to do a little bit more work, okay? Because we don't have a standard thing to do here. So let's do a couple things here. And first, what I want to do is in my toString method, we may have to wipe this out because even though I called it as an override, it didn't really, a virtual, it didn't really do it. So in my person.h now, this is just for my toString. I'm going to leave says hello in a second. My person.h, if I go down to person.h, it says my toString method is a standard toString, right? That's all it is. But I want to decorate this thing with virtual in front of it. So what does virtual do? The virtual keyword, what it does is it indicates to the compiler that this may be overwritten. May be overwritten if I want to. If I make it so that I equal it to 0, so if I change this virtual, instead of doing this, right, if I make it virtual and then I make it equal to 0, as soon as I do that, this person class now becomes an abstract class, okay? Or this becomes an interface. And if I do this, it means that I must override the toString method in my professor class and my student class in order for me to comply with the signature of my base class person. We're not going to do this yet, okay? We're just going to do this right now, okay? So let's just leave it like this. So virtual has got to be there, okay? Cool. So virtual, let's go back to this. If we called this virtual, I'm just going to wipe this away, this toString method, just for now. I'll keep the comments there, but I'll wipe the toString method away from the CPP just for now. And I'm going to go generate it from my virtual method here. So I'm going to go here and create my toString method. Notice that the virtual keyword didn't come across, all right? That's why I did it. I wanted to show you that. So virtual, I want to take this whole thing again. That didn't come across in my toString method. Virtual is only in the .h. All right, so what do I want my toString method to look like? Well, I want to kind of capture all the things here. But here in my says hello, let's do says hello first. Says hello, it's going to return void, right? And all it's going to do is going to be a standard out where it's going to say that, and again, I'll use IOStream here, right? And it'll say, hey, the person's name, so it's going to be get name, get first name, right? The person's name as an example, and then says hello. Okay, pretty simple. And we'll do a standard end line. Okay. Person's name says hello. Now, because it did this, notice that says hello has this little underline. It's asking us to make the function const, which makes sense because it doesn't mean that we're going to return anything anyway. We'll make it const. So that's my says hello function. Pretty simple.
My resharper keeps suggesting static instead of constant for some reason.
Nah, don't ignore that. Don't worry about that. Remember, we can always ignore the recommendations of resharper. Resharper is just a recommendation tool, guys. We don't need to follow it like it's God, right? And sometimes I ignore it too. Like I'm ignoring these things where it says, "Hey, rename this thing to it should be named to set last name instead of set last name." You know, it might say something different for you. I'm just ignoring it because I don't want to work hard here. I just want to keep what I have. This is where we're going to work hard. Okay, so inside of our toString method, what I want is a new standard, an out string. So I'm going to make a new standard string, which we're going to call output string, right? And we're going to initialize it to empty, right? And what we're going to say is our output string plus equals to our first name plus the name of the person, so get name, right? And our output string is going to be plus equals to last name plus the last name of the person. And our output string is going to also equal to age plus the age of the person. Now, our age, unfortunately, is notice it says plus here, and it says cannot apply char const converted from float. We need to convert this to string to add it in, right? And the other thing is that this is going to have as many decimal places. We haven't really formatted it in any way or anything like that. We don't care right now. This is just a preliminary, thing that we're doing. Okay, we can modify this later, but we definitely want to convert this to string. So the way to do that is we're going to use the standard to string conversion, and we're going to modify this so that it wraps it in our age in the toString. I also want to add in some kind of decoration. So output string plus equals here to some decoration marks, just to specify that this is our thing. And I'm going to do one of these, \n, right? And I definitely, one thing to note is that first name, last name, and age, it's going to be added in a row unless I add the last part, right? So the \n, like this. Probably should add these in here too, because otherwise if I don't, then what's going to happen is I'm not going to have new lines. All right, so let's just add those in, right? And I'm going to add the final thing I'm going to put here is in our output string is just another new line character at the end. Maybe we'll make it second, just separate it with a second new line character. First name, last name, age. Yeah, pretty good. Okay, so cool, right? And it says here that we don't have to do this. It says that rename to output underscore string. I'll accept that from ReSharper. I'm okay with that, if that's all it wants. But it wants something else. It says apply clang tidy fix to redundant string init. Sure. So it says you don't need that. I'm okay with that. And I would return, my return type is going to be output string. So that takes care of my person class, guys. Before we move on, right, we haven't included anything else, even though there's errors in my code. If I was to go Control-Shift-B right now, right, there would be errors in my code because my professor has issues, my student also has issues, all right? That's why it's I've got 54 errors. Don't worry about the number of errors. But this person class looks like we're pretty good. Our person class is pretty good, okay? If you missed anything here, I'm going to put this up on GitHub. So I'm going to go to GitHub, right? So I'm going to go to Team Explorer, Home, right? I'm going to go to Changes. I'm going to say I updated the person class. Commit all. I'm going to go to Home. I'm going to go to Sync and Push. So now you're going to have everything up on GitHub for you. So worst case scenario, if you miss what I did, go up on GitHub and grab it. You can always copy paste from there. Next, let's go into my my Solution Explorer and go into the next class, which is going to be my student class. Student class is next. So student.h. Couple things. I want to, at the top, I'm going to say pragma once. So hashtag pragma once. And just like we've done before, it inherits from or it uses person.h just now, okay? But I want to change, I want to standard string. So I want to include string. Okay. And I want to search for all the string references in my thing, just like we did before. So Control A, Control F. You should still have this up here. I want to replace all string references. There's 8 of them. Okay. And I want to just get rid of this void. Student is not void. That's just a star UML thing. And we're good, right? What I want to do here is, it says toString has this little funny mark here. And it says, hey, you know, you want to add an override specifier to an overriding function. I agree. We should add override to the end of this thing. Override means I'm overriding the virtual function toString. So I'm rewriting the toString function specifically for a student. That's what it means. Okay? Let's go into the student.cpp and fix that problem now. So student.cpp, just like before, I want to get rid of the void here. And I want to Control A, Control F, and replace string with standard string. By the way, in future times when we make another class like this, instead of string being the type, I'm going to be smarter with you guys and put standard string inside of our star UML. So it'll actually put standard string in here. Okay? And all we have to do is put in the include. All right, so it gives me an error, and it says that there's a problem here. Now, the first problem we're going to have is whenever we want to inherit from a parent class, so I'm inheriting from person, student needs to satisfy its base constructor. Okay, so the way I would do this is I would use a colon. This indicates I'm accessing the base constructor, right? And then what I want to do is I want to open up some brackets here, right? So again, let's go back and I'll show you what this looks like. The ReSharp or C++ says initialize base person, right? So it's like person, and it's like it's calling the person class the person's constructor from the student constructor. Why? Student is a person and we need to initialize it. There is no defaults for person, right? So I'm going to pass in first name, last name, age. This satisfies the person constructor. Make sense? Because student is a person. Person is also going to be constructed because it's being inherited by student. So therefore, we got to pass in the stuff that makes sense for the person. I also want to kind of initialize student ID. So here, what I can do is, it tells me that. So student ID, do you want to initialize it? And I do. And the way initialization works is the same as what we did before. We just put a comma next to the base constructor. And then m underscore student ID, we're going to move student ID into there. It's almost like a reference, right? And now we have some marks here. So first name, that should be const. Last name, that should be const. Age, that should be const, right? So const float. String, that should be a clang tidy fix for one of these and one of those, right? Because what this is doing is it's saying, hey, you know what? I am getting references to my first name and last name. My constructor now is complete for my person, my student class. All right, student has less to do. Get ID, that's easy. I'm going to go m underscore student ID, and it's going to recommend a couple things, right? It's going to say make function const as well, right? It's asked me to change the name. I'm not going to do that. Next, I want to say that m underscore student ID is equal to value. Here it's going to do the same thing that it did before. It's going to say make this value const, right? And also copy it as a reference, not as a copy. Studies, this is the easy one. Studies is going to say, well, I'm going to do a standard cout, and we're going to say that the name of the person, now this is interesting, the name of the person, I have access to this. I can say get first name. Look at that. Even though I don't have a get first name function here in the student class, because the student class inherits from the person class, it has access to all of its getters and setters. All right, so get first name is totally cool, right? And then now it says a couple things. First name, it says needs IO stream, so no problem. I'll add that in, and then I will just say that is studying. It's not really that exciting. Okay, and studies is also a const function because it really doesn't do much, right? Okay, now the overridden toString method. So I want to get everything that I already had toString, right? And there's a couple of approaches here. One, I could use the Base2string Method, person toString, here, and then add to it, like student ID. So that's one thing I'd like to try and do. So we can call the bases our person's toString method. So I could say something like, because toString, it returns a string, right? So I can say something like our standard string. We'll call this output string again. Output string. That's what resharper is going to make us do anyway. And then I can say something like, I want to plus equals our output string with our person output string. So I'm going to say that output string plus equals to person toString. Does that make sense to you? So I'm actually going to the person superclass, getting its toString method, and then it's gonna convert first name, last name, and age, and add it in as a string. And then I want to add in my own particulars. I'm going to say that, and knowing this, that I'm going to do that, I'm just going to go back and do a tidy fix for my little person CPP. And instead of making two new lines, I'll make it only one new line. So I want to reuse this thing, right? Knowing this. And I'm just going to take some, a copy paste from here, because I'm going to do something like this, right? In my student class. So I'm going to take this, go to my student CPP, and just paste it in, right? And I'm also going to paste in, instead of first name, it's going to be student ID. I may have to adjust this later on, right? Let me just do that again, see what that looks like. That's actually pretty good, actually. So it wasn't bad. So all I do is add student ID, and then I can put this as an output string. Right? Does this make sense? So instead of get first name, obviously it's get student ID. So I'm basically getting the toString method from the person class, because the person class itself has a toString method, and I'm adding it on to my output string, and then I'm adding an additional thing. So that's how I'm overriding or changing the toString method for this class, for student. So it looks like student is complete at this point. I'm just going to upload this to GitHub now at this point, because student looks like it's pretty good. You know, as an example, that's weird. I'm not sure what's happening here. I've got two private member variables. One of them is student ID, and this might have happened to you. Let's see which one we're using in here, because that might be a weird thing to happen. So m_student ID with a capital ID. I think I like that more, so I'm going to get rid of this one. I don't need that one. You only need one anyway. I don't know why StarUML did that. That's just an error. Okay, cool. So I've got my student ID. I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. I'm going to say that I updated the student class. Commit all, right? Home, sync, and push. Yeah, that's right. It's probably a combination of things. Let me make sure that my person class doesn't have that really silliness. No, it's very good with the person class. It's okay. It's just the student class that was weird. Oh, there. This has got to be fixed too. Don't know why I did that. Oh. Student ID. All right. Actually, that was incorrect. There we go. All right. So this is all good. I've done my student, my person. Now, the last thing to do is professor, and then we should be able to finish close to being on time. Let's go to my professor and then test it out. Test it all out. So here's my professor class. Again, just like we did before, I want to add in a guard. So pragma once, right? And I want to rejig. Let's get rid of void. And I want to rejig all the strings to strings before I include the strings. So Control A, Control F, looking for strings, replacing them. 7 occurrences. And then we're going to include string up here. That took care of a lot of it. And I've got my standard employee down here. This is good. It only included once, employee ID. That's good. And we want to make this a virtual. So we're going to say virtual. Oh, sorry. This actually is virtual. We're going to make this override. We're going to have the override keyword at the end, like this. Okay, so override. And we have all these other marks. We're going to go to the other side now, to the professor CPP. And fix all this part. So get this done. We're going to Control A, and we're going to go Control F, and we're going to rejig everything so it's standard string again. 8 replacements. And we need to satisfy the requirements for my superclasses constructor. So that's what this is telling us to do here. So we're going to add our person in here. And just like we did before with the student, we're going to pass in first name, last name, and age, as well as we're going to M underscore employee ID is just employee ID. So that's going to be the stuff that we do. And then let's make sure that we do all those little tidy fixes. So, fix it. So this is a different fix than we did last time. It's totally fine. And it also asks us to do something else. The move mechanics here. And we good here. So now all our constructor looks like it's pretty good. Age should probably be const. Awesome. So that takes care of that. Let's just make sure that this employee ID appears over here for you guys. And we're good to go. The constructor is done from our professor class. Let's move on to my get employee ID. So again, get employee ID is return M underscore employee ID. Employee ID is a const. And here we're going to say that M underscore employee ID is equal to value. Right? And it's going to ask me to do all those tidy fixes. Const. And clang tidy fix. Teaches, that's pretty simple. What I'm going to do there is I'm going to say the same as I've done before, cd standard c out, and we'll say something like the name of the person. So get first name, we'll say is teaching. Is teaching. And it doesn't like C out. It looks like it's an IOStream issue, so we add IOStream in there with 3# or C++, and this is going to be const function. Finally, our Tostring method. Our Tostring method, we're going to do the exact same thing as the student. So let's go and grab the student side of things, and I'm just going to grab all of this so we can save time, not because I want to copy paste. And just paste that in there. Professors don't have student IDs, but they have employee IDs. So we'll say employee ID. This is get employee ID. And that's the only difference between a professor and a student, right? Employee ID and the fact that they have a teaching method. Okay, let's put this up on GitHub. So again, just like before, I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to changes, and I'm going to say that updated professor class. Commit all. Yes, save everything. Home, sync, and push. And then you can see that that is pushing everything up to GitHub. Now there should be no issues anymore. Let us run this thing, and it should just give me nothing. I want nothing. Yay, nothing. Cool, but no errors, which is what I want, right? You should be there too. Are you with me at this point when I've gone through this whole thing? So all I've done is I've constructed my classes and everything else. You should be very close to where I am at this point. Remember, this is what you're going to be handing in today, right, or tomorrow. Thank you for that feedback. All right, so that's pretty cool. We have to modify, we have to test this whole thing. We're going to test it with a test rig. I'm going to go to my main CPP. Here's my main CPP now. And what we're going to do here is we're going to test our class. So I'm going to say, first of all, let's construct a person. I'm going to say person, right, equals to a person. And notice it says, I don't know what person is. Do you mean you want to include person.h? Yes, I do. So is a new person. I'm going to satisfy the requirements. I'm going to say the person's name is Bob, and his last name is Smith, and Bob's age is 35.6 F, because we said it's going to be a float. All right, just to make it interesting. Okay, there's person Bob, and notice it says person. It says we should probably use auto. I'm going to ignore that recommendation right now from ReSharper, but I'm going to say person dot. I'm going to say that I want to says hello, and I want person dot toString, right? So I want to go cd cout, and then we'll say the person dot toString. So this is our first test. Okay, and that's what I have here for testing my toString method. Sorry, my toString method. I'm testing my says hello, and I'm also testing that Bob Smith is 35.6 years old. Let's try this out and run it and see what I get. Yay! Right? I get this. Bob says hello. Bob is his first name. Smith is the last name. Age 35.99998. That's floating point error for sure. That's awesome. And 35.6, which is really weird that we got that. And yeah, right? That's pretty good. But you know what? Let's make a new student now. Let's do that. So we'll say we'll do an extra thing here. So we'll say, what about student? Student. We'll say student, right? Is equal to. Let's add the student.h now. So that's equal to student, and we're going to say that student is their name is Mike, and Mike. I don't know, Jones, some standard names, and that student is going to be 22, right? F. And the student ID, that's what it's looking for. My student ID is going to be A, so MJ, Mike Jones, 1, 2, 3, 4, 5, 6, 7, 8, 9, something like that. And then I want to say that the student says hello. Look at that. I have access to the says hello method because the student is a person. So I have access to all the methods and getters and setters that the person has, right? And the student also studies. And the student is going to do a cout toString method. Okay? That does this. Let's test this now and see if my student makes sense. So run it. And I get the following. I get that Bob Smith is 35.999. Mike Jones is 22. He is also a student with the student ID of MJ, blah, 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 blah. Right? Mike says hello and is studying. Yay! Right? We can tell that this student ID belongs to Mike. Okay? Let's do one last example. We'll say that professor is equal to professor. Yes. And we'll say professor's name is Tom. Me. You can put whatever your favorite professor is. This is my favorite professor. I'm joking. I have a really cool professor that's at Ontario Tech that I really like a lot. Let's use him instead. So instead of me, I'm going to use Andrew Hogue. He's one of my favorite professors. He's pretty awesome. I don't know his age, but I'm going to estimate it at something like 38. And let's say that his employee ID I'm going to make up, right? So again, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there we go. Awesome. And let's go to professor.sayshello and professor.teaches, right? Can't study. Not in this scenario. And we're going to do a cout with a professor and toString. And do we have everything we need? Thanks. Thank you. Does it make sense? So let's see if this runs and what happens to this little test rig we're making. This is our test rig, right? Our little main is testing our function. Oops. And, right? So there's our employee number. There's hello, he's teaching. Andrew Hogue, 38.000, because we haven't done any kind of precision. His employee number and stuff. And you can see that Andrew and Mike both have access to the toString that comes from the person class, right? They have access to those things. They have access to age, first name and last name, even though the first name, last name, and age are not defined within the student or the professor class. They are defined in the parent class. So therefore, we can use our getters and setters from the parent classes. Okay, that's pretty good. But they don't have access. Professor doesn't have access to study. So if I try to do that like we did before, so if I said something like professor studies, it does not compute, right? Doesn't compute. And a professor doesn't have a student ID. Doesn't compute, right? Similarly, a student can't teach right now in this scenario. So teaches, not available. And the student doesn't have an employee ID right now. Okay? At least not in this case. So he doesn't have that access. A person also can't study, right? A standard person can't study, can't teach, and doesn't have a student ID, doesn't come up, right? Or an employee ID. Doesn't have those things, right? So none of those things are possible for a person, right? One more thing to note is, what about if I wanted to directly access my my member variables before we stop? Well, if I go to my my student class, so if I go to student class, or student.cpp, let's say, and what if I wanted to directly access my member variable name, first name? Can I do that? So if I said something like m_first name, yeah, I have access to it, right? Here's my first name. And if I say m first name is equal to something like, Tom, I have access to it, but then I get this really funny error. It says that member variable is inaccessible. Why is it inaccessible, guys? I mean, I can see it, but it's inaccessible. Why is it inaccessible? Come on, this is a critical thing here that we need to do. So I need one of you to answer. I don't want to just tell you the answer.
It's because it's a private data member.
It's private.
Right?
It's absolutely private. And the reason why it's private, and you're like, wait, but private, but student inherits from person. Shouldn't student have access to person? No. Student has access to anything that's public or protected from person. So if I want to make all my subclasses have access to my member variables, in my person.h file, I would change this private to protected. This is not a good practice, nor is it recommended, guys. We shouldn't do this, right? Because we're breaking our rules for object-oriented programming. Sometimes it's necessary to do this, though. So this is a problem solver sometimes for making it protected, okay? But by object-oriented programming methodologies, we should encapsulate or information hide our superclass, and this should be private, right? And we should use our getters and setters like we've been doing. It's equivalent. It's like the same thing. We shouldn't have access to the member variables. The only member variables we should have access to are the member variables of the class itself, the class that we're working in, okay? So again, I would put this as private. And you've already forgotten that it exists, but it does exist. We have access to it. The challenge for us is, because it's a private member, private means only the class itself, the person class, has access to it. Protected means the person class and its children. Okay? That's what protected means. And public, of course, means everybody. So those are different levels of access. All right, so that's pretty cool. We've done all this stuff and we've accessed stuff. Let's go into our GitHub now and finish our thing for today. That's all I wanted to do with you guys today in terms of coding. So let's go into Team Explorer. I'm going to go to Home, and I'm going to go to Changes. I'm going to say added implementation in main.cpp. We'll say test implementation, which is like a test rig. In main.cpp, commit all, save all, home, sync, and push. And now you have your completed code for today. All right? So, learnings. Let's go through this before we go. I know I'm running a little bit late. So we talked about base class is now to start the lecture. Base class is the superclass or parent class of the derived class. We've kind of gone through that. And the derived class is also called the child class or the subclass. We talked about that. Okay? We talked about this idea. Here they talk about cylinders and circles and spheres. You know, a circle is the parent class, let's say, of a sphere or a cylinder, where we can extend, or we can take the circle idea that has a radius as an example, which is a common characteristic of these two shapes. And that's what we want to do. We want to kind of find the common characteristics and create sometimes a superclass. Sometimes we do it in reverse order. We might have had a student and a teacher, and we're like, wait, students have first names, last names, and ages, and so do teachers. You know what? It needs a parent class where we can do a lot of the same work. Instead of duplicating our code, it prevents duplication by thinking about making a parent class first. Okay? So that's what that does. Multiple inheritance is allowed in C++, but I highly recommend against it for beginners, where it inherits from multiple classes. And the problem with multiple inheritance is this idea of a deadly diamond, right? So an example of this would be if I had professor and I had another class over here, right? And let's say the other class also has a toString method. I'm inheriting from this other class and I'm inheriting from professor. Which toString method do I take? Yeah, a teaching assistant. That's interesting. So do I take from so a teaching assistant might be here. So I'm inheriting from both professor and student. So curious, do I take the toString method that's overridden in professor or the toString method overridden in student? Which one? Well, you can't. That's the thing, right? What ends up happening is you might have a clash, and you could have this cyclic redundancy, which is like kind of like I don't know which one to take. So it's more like, sorry, it's an ambiguous reference. So I don't know if it's this toString method or this toString method I'm inheriting. But I get all this. I get both the teaching and the studying, right? Studying and the teaching. I get both those two things. And I also get the employee ID and the student ID. But holy crap, which toString method do I get? Right? That's a problem. And that's why multiple inheritance a lot of times not looked well upon. All right? Because especially in the greater software community outside of C++, C#, no multiple inheritance. That doesn't even support it. Java, same thing. Python does not support it, but well, it can do it, but it's not recommended there either. JavaScript does not allow it, and other languages also do not allow in general. Most higher level languages other than C++ do not allow multiple inheritance because of the dangers of it. Super parent. Yeah, we could call this, remember, we haven't talked about abstract classes yet in a second. So what we've done is we made a class hierarchy is what we've done, right? And what if I wanted there to be another type of student down here? For example, if I'm going to double click on this, you don't have to do this. I'm going to double click on this and create another subclass of student class. And could I not have something called a domestic student, which is a further specialization of the student superclass, right? Is the domestic student, is it a person, right? And let's do another one. And what about this one, right? What about if I have a situation like this? Could I do this too? Here is an international student, right? And an international student and a domestic student, they're like the same, but they have different things. An international student has an international address maybe, and a domestic student has a domestic address, right? So is a domestic student a person? What do you think, guys? Yes or no? I know I'm going a little long. I told you guys I would probably go a little long today. So if you have to go, it's okay. I'm recording. But what do you think? Do you think a domestic student is a student? Check mark for yes, X for no. Yes, right? This makes sense. Domestic student has an is-a relationship with student. Is a student. Thank you for that. How about this? Thank you for the feedback. I just cleared it. Is a domestic student a person? Yes or no? Yes, right? Because it's in the hierarchy. Thank you, guys. So a domestic student then is a student, and it is a person because it follows the hierarchy. And look at these arrows, right? Okay, here's one. Is a domestic student an international student? No. Good. I'm glad that you said that. No, it's not. Definitely 100% no, right? How about, is a domestic student a professor? No, right? You don't have to even put the no. I'll tell you it's no. And you guys, you know, when you make your business rules, think about what I'm doing here. I'm not only creating classes, but I'm actually creating context. I'm saying, think about this. Does the name domestic student is a professor make sense? And maybe if he's a teaching student, something like that. We haven't made a class like that. We could make another class to satisfy to get around a person who is a multiple inheritance. I could make another third class over here. So let's move this over here. I could make another third class in our hierarchy from up here, right? Where I could say something like, here, let's just double click here. And I can add another one. And I could say that this one is a teaching assistant, like we saw in the chat. Teaching assistant. Teaching assistant, right? And a teaching assistant maybe has some characteristics of both the student and the professor. However, there's going to be duplication if I did this, teaching assistant. We may want to think about doing something different here. Okay, and there's another option. And for us, we can do it this way for sure, but it presents some duplication if we did this. Teaching assistant would have some qualities of professor and some qualities of student. It would be a further specialization. Okay. Yes, you can certainly submit your star UML diagram. I think it's a really good thing to do, Dominic, and it's good for you guys to learn that. And the way to do that, of course, is to go File, Save As, and I'm going to save this as, it's an MDJ. We're going to call this OOP3200 F2020, and it's lesson 4. And I'm going to put this inside of my desktop in my OOP3200, and I'm going to store this for you guys when we have a chance. Okay, I'm going to put this up on DC Connect. All right, so does this make sense, this conversation we're having? Because yeah, we can make a teaching assistant, but then we'd have some duplication here. There's a fix for these things, guys, right? We're going to talk about them as we go through the course. There's more to learn than just this, right? Yes, it's okay, Nicholas. All right, so that's what class hierarchies are. We've said private and protected. We can definitely use non-class functions as friends if we want to, but typically not. There's also different specifications, and it talks about that here. So protected and private for our derived class where we can access protected and public, right? We can't access private in our, if it's private in our base class, then it's inaccessible in our derived class. And it talks about accessibility like we just talked about. So protected is the key word that allows us to make it accessible in our derived class. If it's public in our, if it's protected in our base class, by default it's protected in our derived class. You can't change the accessibility to more. You can change the accessibility to less if you want to. You can make it private, but be careful when you inherit stuff. How this is where it starts, and then this is what ends up happening. Right? We have protected, or whatever it is. Sometimes inaccessible. All right, so that is this, and it shows you the cylinder class, and we're going to move through it. Now, polymorphism is kind of what we did already. It talks about something called function binding, right? What we did with the Tostring method, that is an example of polymorphism. Polymorphism, again, we talked about this earlier this semester. It comes from the Greek word polymorphy, or many forms. Many forms. I'm taking that Tostring method, and I'm giving it another form. I'm spinning it into another form for my student class. I'm spinning it into another form for my professor class. And you know what? If I had this teaching assistant, I would probably spin it again to include other things for my teaching assistant class, if I had that, right? So that is the ability for us to override. The idea of overriding and having virtual members where I can override them, that is polymorphism. Part of it. Again, we can use static binding, right? And something called dynamic binding. Static binding is where we actually you pass things forward. Dynamic binding is what we just did with the virtual function. Okay, a virtual function is something that we can override. That's what we can do. Okay, by default, and it shows you some examples of this. One thing we haven't covered today is this idea of the new and delete operator. And this is when we want to use dynamic allocation. If I want to use dynamic allocation in terms of memory management, I can do that. And I can create a pointer to the object instead of a solid object itself. We haven't talked about this, and I'm going to cover it again in another lesson. But really what this means is if I go to my test rig here, right, in my main, really quickly, here's my main, I could make an array of person objects, or an array of as an example, students, right? And the way I could specify that, and we're going to talk about that later on, let's make a standard vector. So say I'll make a standard vector. You guys should know what this looks like by now, hopefully. But a standard vector, and let's add vector to our types. So include vector. Don't think about a vector like my little vector 2. A vector is like a collection. We're going to talk about collections starting next week. So this is where this is going to come in. This is a preview of what we're going to be talking about. Standard vector of type what? Of type person pointers. I can do that. I can say a standard vector of type person pointer called people. Right? Person pointers called people. Right? If I want to instantiate, I want to push back into that vector, I could do something like this. I could say people, and don't worry if you don't know what I'm doing, push back. I want to add something to the vector. I could add a new person where I can give that person the name of Alvaro, right? And the name of his last name is Quevedo. He's another favorite professor of mine. And his age, let's make him pretty young at 32, right? Okay? And what I've done is I've allocated memory with the new keyword, dynamically allocated memory with a new keyword, right? This is something we want to do. And when I want to access Alvaro, right, the person Alvaro, what I want to do is I want to do something like this. People. And let's say the first person in the people vector, I want to say, which his name is Alvaro, I want to say, well, they says hello, right? I want to say the says hello function. But because I'm using a pointer, I can't use the dot accessor. In fact, what I need to do instead is use the arrow notation. And that's the difference. I can't use a dot. I have to use arrow. Arrow means pointer. I'm using people0 because I'm adding an object of type person to the people array. Think about a vector as a super array that allows you more control, let's say. And I can always say that people 0, or the first person, the 0th person, also is going to, I want to output toString. I want to output that person toString with the arrow function. So, right? Okay, so this is something that I can do. And I've done a bunch of different things here. So this is dynamic memory allocation with objects. Okay, that's what I'm doing here. So let's run it. And you can see now at the bottom, Alvaro Quevedo 32, Alvaro says hello. Right? So you can see the same thing that we got before, but I'm accessing it in a slightly different way. And I've got a people vector. Now I've allocated memory with a new keyword dynamically. And in another context, I'd have to delete the memory that I've allocated later on and clean up. Right? So for example, what I'd want to do is remove the person from the vector, right? And then clean them up, or clean up the memory. Because if I leave it, I'm going to have a memory leak if I leave it like this. Okay? Let's go back to this. So that's what the new and delete keyword. New allocates or reserves, dynamically allocates memory. And we'll talk about memory allocation later, right? And delete goes through and deletes pointer, like something that, my memory that I'm pointing to, as an example. So when we talk about pointers. And here's an example of that. So checkout is another transaction. Another transaction is equal to a new checkout. Let's say if checkout was the checkout class, right? And I've allocated memory. That's what I'm doing. I'm dynamically allocating memory for this type. We have that a lot, and it talks about the memory leak idea here. I'm going to go into more detail about memory leaks and what this is all about in another lesson. And it shows you how to do that with a pointer to a book title. So here's a pointer to a book title. It's a new book. Let's suppose I have a class book, right? Here we are. We have the constructor function, and we have show title. And then what we can do inside of the implementation on the CPP side, we can say that we want a string copy from the name into the title. And we want to show the title by cout title, which is just the name, a string. And when we use it, the book, we say, I want to make a new book. This is just allocating regularly, right? I'm allocating regularly. And I can access each member. There's 2 different books here that I'm creating, right? 2 classes. But I can also do it with a new keyword. And what the new keyword does, and it talks about how to, what this all does in terms of addressing the first allocated location. All right, that's what this does. String length name plus 1 is the first allocated location, right? Using pointers, okay? So we're going to talk more about this as we go forward, okay? I'm going to skip this because I want to get to that point where we use the new keyword later on, right? And if you read the function here, what we're doing here is something else. So here I have my operator, and notice that I'm creating a title which is temporary, right? I can delete or release existing memory from my my title by using the delete keyword, right? I delete it, release it back into the wild. And I can allocate new memory by using the new keyword. This is dynamic allocation as opposed to the other type of allocation we used before. And here's something you should know. When we allocate memory, I'm just going to put this out there to you. So a high-level lesson we're talking about right here from a memory allocation perspective. It allocates memory in different places. The regular allocation method, like we've shown here in our main, so if I go back to main, the regular allocation method that we've seen before, which is this, right? This allocates memory on the stack. Okay, stack memory. This allocates memory dynamically on the heap memory. We have much more heap memory than we have stack memory. Okay, just letting you know. And this is the preferred method when we're using objects. If I want to allocate memory of many, many objects, I'd probably use some kind of pointer to them. Okay? Why? It's dynamic, right? It means I can allocate memory in chunks, right? On the heap, not on the stack. So I'm not going to get potentially a stack overflow if I allocate lots and lots of stuff. Probably I won't, because nowadays computers are huge in terms of memory allocation. But this is definitely kind of a better way. However, raw memory management with the new keyword and the delete keyword is something that we want to move around. And we're going to talk about maybe smart pointers maybe in future lessons. All right, so that is, again, new and delete. New allocates memory dynamically. Delete deletes or frees up the memory that we allocate dynamically. We talked about the virtual keyword. The virtual keyword basically triggers, a different kind of binding. We talked about this, the idea of dynamic binding. Dynamic binding is done by first indicating that the object we want to bind to is virtual, right? Whatever that is. And that's what, for the most part, what this covers, okay? This lesson. We also talked about UML. You guys should know about that. And I also talked about what these things are. You should know way more about UML than you've learned or we talked about before, okay? So that is what this thing covers. Now, one thing that I'm not exactly happy about that we did cover is this virtual keyword, but what we didn't cover a lot of is this idea of making an abstract class. So let's think about this, and this will end today in terms of our lesson. Curious to you, does it make sense that we should even have a person class? And what I mean by that is, should I be able to create a person class, an instance of a person by itself that's not a student, not a professor, not a teaching assistant, not anything specialized? Is anyone in real life like that? A person who has completely nothing, right? No. And even if the person doesn't work, they're out of work, they're unemployed, it's an unemployed person, okay? There's an employed person and there's an unemployed person. We can actually make additional hierarchies and layers here, right? Where an employed person, as an example, might have an employee number further up the chain, right? Unemployed person, as an example, this is where you can add employee numbers to both students and professors. If you're an unemployed professor, you may not have an employee number. If you're an employed professor, you have an employee number. If you're an unemployed student, you don't have an employee number. If you're an employed student, you have an employee number. So you can add employee numbers wherever you want, right? But nobody in real life has no role. Like there's no role. They're not a parent. They're not a teacher. They're not a student. They're not a child. They're not anything. No one's like that. They all have we all put labels on something we see in real life. I'm just telling you, generally, Nicholas, we don't have that. But yeah, generally we don't have that situation, right? So because of this, the person class itself, if you think about this, right, shouldn't be something we instantiate. We want to force people to specialize, either student, professor, teaching assistant, or other, whatever it's going to be. In order for me to do this, right, I would not define my person as a class that I can instantiate. I would want to mark this class as abstract. Okay, so the way to mark this class as abstract here in UML, right, is you click on is abstract. What that does for us is it makes the class itself, the name of the class, italicized. That's all it does. Okay, so that's the difference between person and what it was before. Is abstract. Okay, how do we make it is abstract? How do we do this thing? As an example, how do we make is abstract happen in C++? Well, in C# you have the abstract keyword, right? No, it doesn't have all virtual functions, but they have to have they can have virtual functions as well. The way to mark the class as abstract, if I want the person class to be uninstantial, we can't instantiate an object of type person, is in C# we would just put the abstract keyword. If we're learning C#, abstract class person. Here in C++ we don't do that. What we do is we have a constructor, right? We have a constructor function. A destructor, I mean. And what we want is we want a virtual destructor. So virtual destructor, and we want to mark it as pure virtual. This pure virtual marking of the destructor is the syntax we use, right? We say that the destructor is virtual keyword. The destructor is mentioned, the name, the actual thing of the destructor, and is equal to 0. This equal to 0 marks a method as pure virtual, something that needs to be overridden, must be overridden. Okay, that's what this does. I could also mark other things as virtual, like I did before. For example, the Tostring method. I could mark that as pure virtual, which means I would not have any kind of implementation at all in the C++ side. Now let's see what that did. When I just did this, did it do anything to us? What did it do for us? So if I go back into the main now, notice that my person object says it doesn't compute. I can't do this anymore, right? Look it. It says person is abstract, right? Take care, Nicholas. I'll finish up here. Person is abstract. It's marked as abstract because it's a pure virtual function. So I can't do this anymore. So person is abstract. So I can't instantiate. We can't. We'll say we can't instantiate object of type person. And what does abstract mean? It means we can make a blueprint, which we did, but we need to make subclasses. We must make subclasses because those make more sense than anything else, right? So we can comment these out. Because there is no way. We can't do this anymore because person is abstract. So none of that computes. And because none of that computes, so too does this person here. Let's specify our person here. Instead of making a person, we're going to force Alvaro to be a professor. And we can add in a employee ID. Okay? Now, but we can say, this is something interesting. We can say that people are of type person. Why? Because a professor is a person, I can add that in. And I can also add in, we'll talk about this later on, I can also add in other types of people. For example, a student. I could say people.pushback a new student, which with his name is Nick, right? And we'll say his last name is, I don't know, Smythe, Nick Smythe. And he's 20 years old, right, as an example. And he has a student ID of Nick Smythe. Okay, whatever. Okay, and we can say that people 1, says hello, right? We can do this. We can also say that people 1, right, so the first person, is studying. So here's something else. Notice that I can't do, even though I know as a student, I can't do studies. See that? Look at that. I can't do studies. Why not? I know the person is, this person is a student, but I can't do studies because this vector doesn't know about students or professors. All it knows about is persons. So it doesn't have studies. Person doesn't have a studies. Only students and professors do. And if you find this confusing, it's okay. How do I fix this? It says create member function studies. No, that's definitely not what I want to do. I could cast this person, this people 0. I could static cast that as a student, right? As an example. But studies is not something that I can't use the specialized function inside of when I refer to this object as a student. I can't do that. However, when I run this now, both the student and the teacher, right? I can still sorry about that. I can still run this thing the way it is right now, because oh yeah, this problem. It says one resolved external, and whenever you get this, it says person. So public virtual this call. It says here's another thing that you'll get, right? And it says inside of the student object and this. Let's just make sure. Sometimes what I find is if I clean my solution and if I rerun everything, it's okay. Sometimes, right? We shouldn't get an error. We shouldn't get an error right now. Oh yeah, why are we getting this error? Because it says public this call person, right? It says reference to a function public virtual this person professor. Oh yeah. So that's something that we reference actually a member of the professor class or the person class that was done a little differently, right? So notice it says line 1 in main, right? We're referencing it here, and what we shouldn't do, we can do this for sure, but let us, what if I comment, just curious, what if I just commented this out for a second, and then I'll do that, and we'll go through it in a second. Just one sec, okay, while I do this. And then I want to see if that's going to fix it. Probably not. And I hate when I get this error. It's a linking error. One unresolved external. I'm going to come back to this in a bit. I'm just going to go and I'm going to comment out the person class just for a second. Let's see if that fixes it. Nope. It has to do with that virtual destructor in the person class. The virtual destructor, this pure virtual. Once I mark it as pure virtual, we have to also have a destructor in the other classes as well, right? So we're not going to go there for now. I'm just going to undo this pure virtual stuff, and then because I'm timing out too, and I got to show you what this is later on. There's too much code to put in now that I thought about it. I'm just going to go back to my main. It's not pure virtual anymore, and I'm just going to uncheck all this. This will totally work still now. And that shouldn't be a problem anymore. Yeah. So we'll go back to this, and I'll talk about the private the virtual destructor, and talk about what that does. Okay, lots and lots to do. Thank you so much for the people who stayed on. Please, for those people who are watching remotely or staying on, let's make sure that you hand in your in-class exercise. Which is due, that's 3, that's due today or tomorrow, and your lab 3, which is due Sunday. Guys, thank you so much. That's it for me today. I'm going to stop recording, and I'll stick around for any questions you might have.